Good morning, everybody. My name is Cindy Martin Brennan. I am a member of the board of Space Tango, and I'm very pleased and honored here to moderate, interview Dr. Camille Alleyne from NASA Johnson Space Center. So I'm going to do a small introduction, though this lady has quite the bio in her life, and she's pretty an amazing, astounding woman that I actually met back in the 1990s, ironically, but we were youngsters then. So Dr. Camille Alleyne is a rocket engineer. She's internationally acclaimed speaker, writer, educational leader, science ambassador whose accomplishments in the field of space exploration have been extraordinary. She is truly extraordinary. In the highly technical fields of ours, science and engineering, where we women are the minority, she is one of the most recognized women in aerospace engineering and one of the few women of color to serve in a senior leadership position at NASA. Dr. Alleyne has dedicated her 26-year career to advancing the areas of aerospace, space technology development, specifically in the areas of human spaceflight, space vehicle systems, engineering, and space, or in other words, microgravity research. Dr. Alleyne is also an expert in the area of space, science, and technology application in international development, specifically focused on developing countries. Currently, she serves as the Deputy Manager for Commercial Low Earth Orbit Development Program located at NASA Johnson Space Center in Houston, Texas. In this role, she is a lead architect for enabling space economies in low Earth orbit. Prior to that, she serves as the Deputy Manager for Commercial Lunar Payload Services and developed the foundational strategy towards the commercialization of our moon. She also serves as the Assistant Director Associate Administrator for programs in the Science Mission Directorate at NASA headquarters. Science Mission is where we're seeing a lot of our NASA science, exploration science, our rovers, et cetera, are coming out of that directorate. So she assisted there as well as a Associate Deputy Administrator. She has also served as Associate Program Scientist for the International Space Station, where she developed and managed innovative strategies for the commercialization of low Earth orbit. All this stuff I'm reading off, you can tell she has a long history and her expertise is valued by industry. In addition to that, she's renowned for her work on global STEM education for girls, which she does through Bright Stars Foundation, which is a 501c3 nonprofit founded in 2007 and dedicated to educating, empowering, and inspiring young women to be future leaders through the study of science, math, and technology. She holds a Bachelor of Science in Mechanical and Aerospace Engineering from Howard University, a Master of Science in Mechanical Engineering from Florida A&M University, a Master of Science in Aerospace Engineering from the University of Maryland in College Park, Maryland, and a doctorate in educational leadership from the University of Houston. So she's an underachiever, as you can see. So with that, I just want to add a little personal note. She was born in Trinidad, Tobago, same where Danny's origins come from as well. She's a licensed private pilot, including she was a finalist in 2004 astronaut selection for NASA. She's received numerous awards and commendations from national and international organizations, included being awarded Women of Color in STEM All-Star Technology Award, Outstanding Woman in Aerospace by the National Society of Black Engineers, and Distinguished Alumni, deservingly so, from FAMU College of Engineering. She is a space and science diplomat for the U.S. State Department and is also recognized as one of the Caribbean's icons in science and technology. So with that, Dr. Alleyne, again, it's a pleasure to see you again, and it's a joyful experience to share this career of ours over the span of many, many, many years. So thank you for allowing me to ask you questions.
Thank you for having me, Cindy, and it's a true honor and a pleasure to be here with you, and I'm excited about our conversation. So thank you for having me.
So I said quite a few things about you, and a lot of it is a NASA lingo. So I'm trying as very hard as possible because a lot of our audience here are biologists from Select Bio, and they may not be familiar with NASA and their lingo. So I guess the words I said, if you could sort of talk a little bit about your position. What does Deputy Manager of Commercial Low Earth Orbit, what do they do? What are they responsible for? What does your day look like?
Yes. No, thank you for that question. It's an exciting time, right? In space commerce, and the commercialization of space. And I know that NASA is at the forefront of enabling commercialization in low Earth orbit and on the moon. And we can talk about that later. But specifically, our program was stood up in 2019 to develop and enable a sustainable and robust economy in low Earth orbit in a way that NASA could, one, have a sustained presence, a sustained human presence in low Earth orbit as we go on to, execute on the Artemis mission, sending humans to the moon and eventually onto Mars. We want to continue to have a sustained presence in low Earth orbit. But we also want to be one of many customers in low Earth orbit. And that means that we have to develop that ecosystem. We have to help enable and invest in companies that can really execute and implement on that vision, right? And so our office is specifically responsible for not only enabling the commercial space stations beyond the ISS end of life, which now is extended to 2030. The report came out a few weeks ago. But also in enabling the supply side of that equation, is also, it requires us stimulating the demand side of that equation, which we are doing through the private astronaut missions. We're doing that through the commercial marketing and advertising on the ISS, a 5% allocation of the NASA, resources dedicated to commercial advertising, marketing, and entertainment. And also being an incubator for future potential markets, such as in-space manufacturing and production. So all of those pieces come together under our program. And those are the parts of our portfolio that we are managing.
All right, thank you for that explanation. I do want to add, so I have the privilege here of having a back and forth with you of questions. I do want to let everybody know who's listening right now, if you do have a question, go ahead and raise your hand. We will be monitoring the chat. We will unmute your mic. You can ask the question and then allow Dr. Alleyne to answer the question. So I just want to add that little piece of housekeeping. So your office, as you were saying, is transitioning, NASA's big vision is transition from low Earth orbit, right? So right now, NASA runs most of that programmatic infrastructure, right? They are, well, SpaceX is providing the transportation, Northrop Grumman's providing the transportation, NASA's buying the transportation. So NASA's done a fabulous job in setting up kind of that infrastructure. Your eye next, being NASA, is really, and correct me and add where, but your eye is really providing that next infrastructure, not transportation, but these platforms that's going to allow transitioning from the International Space Station, which is now sort of government funded and owned and run, transitioning to a set of commercials platforms, either one or many. We don't know that yet, but your program is kind of enabling that runway, that pathway, that strategy.
That's Cindy, let me just add to that. That's you're spot on, right? We see it as a three-leg stool. Cargo, we started with cargo, right? With the cargo resupply. And the precursor to that was the formulation phase, which we knew as COTS. The second part of that triangle was the crew part, right? Which became known as the Commercial Crew Program, which is what you're talking about, launching our astronauts from American soil with SpaceX and eventually Boeing. And now the destinations is the third piece of that trifecta of what we see as the full LEO economy, right? And so that's the platforms that these transportation services can go to commercial platforms. And so that's what we're enabling.
Right. And for companies like Space Tango and a lot of hopefully researchers are on the line, that platform, that transition to those destinations, those human rated destinations in low Earth orbit. And let's be very clear, it's low Earth orbit, 250 miles up. But those destinations are going to be very important to companies and academia and other government agencies because right now the International Space Station is being used to develop and test these innovative technologies, driving biological investigations, advancing, as you were mentioning, manufacturing earlier, biofabrication, biomanufacturing, microfluidics, cell and gene therapy, organoid and organs on a chip. So the strategy you are putting in place is incredibly important to us in our industry and incredibly important to the US economy. So can you elaborate a little bit on that timeline, what that strategy looks like? I know there's like 4 companies that are possibly in contention, but if you could elaborate on that strategy, elaborate a little bit more on that timeline. And you said ISS goes to 2030. But what does that look like? When does a shift happen to a commercial statement? Because we know it's not going to be an off the edge type of thing. It's going to be a transition. So can you elaborate a little bit more on that, please?
No, that's a great question. So right now we're in the formulation stage because we actually only awarded back in December 3 of the 4 awards have gone to free fly companies who have architectures for free flying destinations, right? That's Blue Origin, Nanoracks, and Northrop Grumman. And the 4th one is a contract with Axiom Space, and their architecture is predicated on being attached to ISS first and then becoming a free flying space station, right? So yes, so the 4 of those constitute commercial LEO destinations. And so we are looking at the next 3 years as the formulation and development phase for these companies and their platforms and their architectures. And then in around the 2025-26 timeframe, we'll be transitioning to both a certification and a services contract, or what we call phase 2. And so that will be where so requirements will be levied on these companies, and they will have to be able to certify their destinations to our requirements. And then we are going to start procuring services from those destinations. Now, our goal is to have a 2-year transition from ISS to those platforms. So if ISS end of life now is 2030, in 2028, we will be starting that transition. As you said, it doesn't just one day you shut off ISS and then you turn on the destinations. It's not going to happen. So that's it. We plan for a 2-year transition, and then in 2030, fully operational with the destinations. And there is a policy out there that government is not supposed to compete with commercial, right? And so once those destinations are up and running and they can actually provide the kind of services that we are looking for, which are in the area of research, then we wouldn't be able to compete with them. So that's the plan. Right, but it's going to take time. This is not going to happen. Space stations are not going to be built overnight. So we are hoping that, the next few years gives enough runway, and the companies are moving extremely fast.
Yes, I see that with all the companies you mentioned. They're thoroughly investing a lot of their own funding too, and that is very important too. NASA is putting a piece of the funding in, right?
An investment. We call it an investment.
Right. So, but the companies have to come to the table as well.
Absolutely.
It is a partnership for sure. So you mentioned NASA has a set of requirements, that when you go for the second phase of this, there's requirements that you need, services that you need that you want to procure from 1 of 4, 2 of 4, 3 of 4, will depend a lot on the federal budget, I believe.
Exactly.
And now, how do you foresee, so NASA services, but then they also have to kind of make it as a company. So, because NASA's only a small piece of it, right? So now they also have to grow markets. So yes, NASA's going to be kind of a buyer of these services, but a space station provider probably will not be able to exist just on what NASA pays them,
That's
basically.
right.
So how do you see kind of the market? So how, besides the supply side that you're working, how do you see the market, the demand? How is NASA kind of helping sort of enable some of these emerging markets that will
Yeah, so
help these providers?
So you're right, we'll be one of many customers. And the hope is that the commercial destination companies will have to go out there and they will have to create their own business to business agreements, right? And partnerships. But we recognize that the government, this is a very nascent industry, right? And like other industries that have developed, I mean, we reference the aviation industry a lot, because in the beginning there was a need by government to have faster access to, transporting mail and stuff like that. And so the government built the infrastructure, they invested in the infrastructure, and out of that, commercial endeavors were able to spawn, right? And it's the same thing here, and we're in the very early stages. So we understand that we play a role in incubating some of those markets, right? Investing in some of those markets to be developed. And so we take our cue from the market research. We commission market studies, right? Companies to go out there and tell us where are the promising markets, and how, and should we invest in those promising markets, so that once the supply platforms are there, that market is mature enough to be able to be sustainable and robust, right? And so that's the model we are following. We're investing in space manufacturing because the market research said that is one of the more promising and potential markets down the road. And so we're trying to help catalyze, that business case to be sustainable.
Right, and I can affirm that you're doing that, because we have Dr. Wagner speaking later today on, well, it's very early stage R&D, like a lot of this, but the retinal implant manufacturing in space, that's an end goal that the nation has, to kind of demonstrate this sort of layer by layer deposition on things that need microgravity. That's very key, and I think you said it earlier, things that need microgravity, the products, the services that need microgravity. This is a very special place to do it. And the manufacturer, I'm really glad to hear that you see, that is a market that needs to be tapped into. And as you recognize, it's very nascent as well. With regards to that kind of manufacturing in space, again, there will be platforms 2028, 2030, hopefully sooner, commercial platforms available, options available, more than one, so we can, enable that competition, competitive pricing. Absolutely. But some of the manufacturing, it could be possible that someday you don't need a human in the loop for manufacturing. If you want to do, for example, the retinal implant work, it has to go through FDA at some point. We have to have, good manufacturing processes in place for FDA to approve these implants, because they will end up, in somebody's eyes someday. But in order to do that, you have to have a very good manufacturing process. And sometimes the simple manufacturing process may be not a human-rated platform, maybe a self-autonomous platform, not a human-rated platform, may be the solution to do manufacturing in space, to keep things kind of clean and simple and controllable within a logistics supply chain as well. Has NASA given any thought? So we're looking at these 4, contractors, vendors to do human-rated work. Has NASA given any thought to these autonomous platforms to do kind of these manufacturing applications that may not need a human-rated platform?
I am not sure we've given much thought to the autonomous platforms because our goal, right, and our mission is a sustained human presence. So we are invested in enabling human-rated platforms, right? But I would say that the competition is going to be wide open. We're going to put out an RFP, and even beyond those 4 companies, other companies with potential business cases and technologies that can help us reach our goal can compete for those, right? And if that is an autonomous platform that can demonstrate that they can do the type of technology research that we need, we are very open to that. But it has to be something that we need and it meets our needs, right? As a government, we won't just invest in something that does not support those goals, right? So if there's only a business customer for that particular technology, then the onus is on that company to actually develop that business case without the involvement of the government. Does that make sense, Cindy?
Yes, entirely. And that is consistently, what has been, we've been kind of sharing and thinking as well. So one more question I ask a little bit, but then I want to kind of dive a little bit into your career and your path. But one more question with regards to NASA requirements and using this station or stations in the future. What would it look like? Say I'm a scientist in 2028. I've received a NASA grant to do some organoid research. Maybe it's NIH, maybe it's another agency, maybe I'm a university. What would that look like? I received that grant. I don't have the ISS anymore. What will it look like? What will be provided to me as a researcher for a commercial platform? How will NASA be helping me to get my research to microgravity? That's a crystal ball question.
That's a great question, because we are in the beginning stages of putting that strategy together. That exact question. And right now, there's the ISS National Lab that researcher would be sponsored by, right? And then there are the NASA goals, the NASA researchers that do research to support NASA's mission. So those are the 2 pieces that really make up the NASA allocation on ISS. As we transition to commercial destinations, there's still going to be the NASA researchers that are doing NASA goals. That's actually the services that we are going to provide, that we're going to be procuring, right? But we also intend that there will still be an ISS National Lab component that will serve the function that they're serving now, which is sponsoring other government agencies. And we're talking with those other government agencies now to see what their forecast is for the type of research they'll be interested in, albeit it's really early and nobody's really thinking 10 years in advance where we want to be, but we have actually started engaging the NIHs, the DODs, the Department of Agriculture in those discussions, informing them and educating them that this is our strategy and that this is how we plan to transfer from ISS to commercial destinations. So they need to know that there is still going to be a presence in low Earth orbit that serves the US government. And then they need to start thinking about, okay, how is there a role for us then? Is there a need for us to utilize those platforms, right? So that researcher should still be able to go under the umbrella of an ISS National Lab type function, right, to get their research to the destination and to utilize the destinations, the commercial platforms. But we are still in the very early stages of what that looks like.
Yeah, well, I'm happy that it's being undertaken, the discussions, because they're
Oh
not
no, we
answers.
do. It is totally part of our discussions, and in fact, our international partners too. That's another component of it. So we are having those discussions too.
Absolutely. So switching a little bit to you in your career. So we found out that back in the 1990s, you and I worked together, right? At NASA KSC, in one building, we worked something called Space Lab, which was a kind of a platform that was in the Space Shuttle cargo bay. And you and I worked that back in the 90s. So
those were the early days of research. Those were the early days of research, right? Cindy, before
they
the
were
ISS.
pathfinding, yes. And we were 10 years old. We both started our career as NASA engineers. So at the time, there weren't too many women, and even less women of color like yourself. So, but look at you now, you're advancing your career you're in a senior leadership. You've had several senior leadership positions, but you've really advanced your career. Can you share what challenges and some of the lessons learned along the way in your career as a woman of color from 1990s to today?
Yes, no, great question, and thank you for that. Oh my gosh, where do I start? The lessons are long, right? But I would start by saying, of course, we all talk about mentorship and the importance of mentorship, right? You can't advance through your career without that. Either going to seek out mentors, people who are in positions that you aspire to, or potential mentors seeking you out, right? And saying, I see something in you and I would like to mentor you because I see where you could go. So that's one thing, but that's just one of the pieces. Two other most important pieces that I have come to recognize actually later on in my career is the importance of advocacy and sponsorship. Right? The advocates are the ones who are talking about you when you are not in the room. A special project comes up and they say, oh, have you thought about Camille for this? She would be so good on this team, right? That is advocacy. That is so critical. And then sponsorship is actually people saying, it is time to advance her to this next position. I think she will be great in this role, or she'll be great leading this program. And those two things you absolutely have no direct control over, but it comes out of I think the quality of your work and the relationships that you have built over time, over the course of your career. And so those are the two things that are really, really important to advancing, I believe. But for women, especially, I have struggled with this, and I've seen a lot of women struggle with this, is really having the confidence in yourself and knowing that you have a voice, right? And really leaning in and raising your voice, speaking up on issues, speaking up on giving your opinion or sharing your experiences. That is really, really important, especially in the environment that I am in, because that is how sometimes you are measured. That's how your worth is measured. And people start recognizing that, oh, wow, this is a potential leader, or this is a leader, right? Because she has all these things to say, or she brings all these unique and diverse perspectives and ideas to the table. And that's what we need. And so I think for women, we need to learn to really value our voice and our experiences, our perspectives, and what we bring to the table, and have the courage to speak up and share that. And I think, between the mentorship, advocacy, and sponsorship, and finding our voice, and those are the things I feel like have been the most pivotal in helping me to advance through my career.
I love hearing that about a voice, and it made me think of a Madeleine Albright. She's amazing, but she
I
talks
love
a
her.
lot about,
It's
and
incredible.
she said, yeah, she says, once I found my voice, I was continue to use it. I was not going to shut up.
Absolutely. I see that too. I didn't find mine till about my mid to late 30s, but I would say you can shut me up now because, yeah, I know I have something to say and I'm going to say it.
And with
And that
that, my
people want to
dear,
listen too, so that helps.
yeah, so having a voice and having people listen and respond to it also is very important. With that, I believe it's at 11:45. I really appreciate your candidness in this conversation, and truly it's been nice to get to know you again. And I look forward to having some of these side conversations that you and I we're fond of Friday night over a glass of wine or water. So
I look forward to it, Cindy. Thank you so much.
yes. All right. Thank you very much, Dr. Alleyne.
Fantastic. Thank you so much for such an engaging conversation. We're getting an outpour of support in the chat, especially those that are thinking for, emphasizing the importance of speaking up. I know that's something that, Camille, that was something you first taught me actually when I met you in 2017 at my first ISS R&D conference. And then Cindy, something that you continue to instill in me as one of my mentors at Space Tango. We do have one question that was asked in the chat. Are there specific research areas NASA will be focusing on for low Earth orbit research? Thank you.
Yes, great question. The research that will be prioritized will be research that supports our exploration goals, right? And one of the reasons I didn't mention this to Cindy, one of the reasons that we feel commercialization is really the way to go is that not only does it bring innovative solutions to the table, but it drives down cost for the government. And driving down costs for the government allows us to take the extra funding and put it towards exploration and put it towards the really hard missions that usually the government needs to do first, right? Humans to Mars, for example. So our research that we are starting to pull together that will use those destinations in the areas of biological and physical sciences. Some of the things that we're doing on ISS now, technology demonstration. How do we advance our ECLIS systems? How do we advance our robotic or autonomous systems that help us explore the moon and Mars and beyond? Right. So those are the kind of research that we'll be focused on with those destinations.
Perfect. Thank you. We do have another question. How do you invest in companies like Space Tango? So Cindy, maybe this is a good question for you, as well as I'd like to also add to that, just an emphasis on what are some of the grant opportunities to participate in some of the NASA LEA activity, whether that's as a current ISS user or a future CLD platform.
So I think the question is kind of stemming from how do you kind of get the opportunities to go to microgravity on the ISS? It sounds like that question is asking how to get involved, where are the investments, where the funding. So I'm going to make that assumption with the question. And if I've gotten it wrong, re-ask the question and I'll try again. But there's a couple places for Space Tango. We work with quite a few different organizations, actually. They're federal organizations, and there's one nonprofit we work with. The nonprofit is an International Space Station National Laboratory, where they have a website. They are a nonprofit organization that runs 50% of the US portion of the International Space Station. And they are constantly putting out solicitations, calls for research, development, technology development through their website, looking to kind of foster some of this in R&D that will lead to the sustainable growth and demand that Dr. Alleyne referred to. The other place we look at, and also let me back up a little bit with International Space Station National Lab, they work very closely with NSF and NIH, and they will put out joint collaborations, funding opportunities. If you're a researcher and cell and gene therapy, organ on a chip, lab on a chip, I would recommend you go to that website, International Space Station National Lab, because there are funding opportunities and opportunities to do research there. The other place that we, Space Tango, also look to is at NASA, called In Space Applications. There was a solicitation. Alleyne, it's closed, correct? Yeah. So do you want to talk a little bit about the InSpa or opportunity?
Yes, so we just put out another RFP actually under the ISS National Lab, at the ISS research. The International Space Station program is sponsoring that in-space manufacturing as a follow-on to the ones that they did a couple of years ago, right? And again, that's the next evolution of, okay, we are looking at the trend of the development of the market, right? So how do we continue to invest to foster that the maturity of that market? And that's what that RFP is looking to do.
And thank you, Liam Kennedy, for posting on the chat the National Lab solicitations. The solicitations that NASA puts out, I think you can access it from the CLD, the Commercial LEO Destinations website as well. I think there's links there.
Yeah. Well, actually, we have a nasa.gov/LEO economy that you will find all the solicitations, either for the in-space manufacturing information on the CLDs, or any other ways that we are trying to build the economy.
Right. And there's actually a third opportunity as well that isn't so well known, is that there are quite a few of us, like Space Tangos, and we have Stephanie Countryman from BioServe also going to be speaking later today. We're called implementation partners. So we have access to the International Space Station. We have agreements with NASA. So you can directly reach out to our companies and start developing a discussion about research, what type of research you would like to do on the station, why you think you need microgravity, or why you needed to do technology demonstration. If you have microfluidics that you want to test in space, and there's reasons to do testing in space, you can reach out to us. So you don't necessarily need a federal partner to get access to space. Of course, we need NASA because we have that collaboration agreement with them, but you can reach out to companies like ourselves. I hope that answered the question. Danny, was that pretty much the context of the question?
Yes, thank you. Perfect. And then we do have a few more questions. Let's see, from Liam Kennedy. In my work, I get questions about conducting research on the ISS from organizations outside the USA. Can you share how non-US persons or organizations can get their experiments on the ISS?
That's a tricky one because you will have to go through the international partner, the ISS partner, to get your research through. So, for example, JAXA, you can go through JAXA, depending on the country. They can go through ESA, but they have to be sponsored by one of the International Space Station partners. The ISS National Lab is solely for sponsorship of US entities, with the goal of having a benefit to Earth. And so it would be almost, I wouldn't even say almost impossible, because I know there are companies who have shepherded other countries, especially in the area of STEM education, through the ISS National Lab. But usually countries will have to find an international partner who will be willing to sponsor their research to the ISS.
Right, and to add to that, Liam, yes, Space Tango can work with international organizations. We currently do, and we do that through the International Space Station National Laboratory. For access to kind of the federal funding, again, you work through the international organization, the international governments. It's always very helpful to have a U.S. partner for a U.S. research partner. But yes, so Space Tango, we can work with international organizations, and we work with CASIS, or the International Space Station, with regards to that.
Dr. Alleyne, can you talk about the role of international cooperation in NASA's plans for the moon, starting with the Artemis program, and how in tandem is that related to commercial LEO development?
Oh my gosh, I'm way out of my wheelhouse. I know the Gateway, which is the lunar outpost that we are developing, has international partners. Japan, Canada, and actually the UAE are part of that Gateway agreement. In terms of humans to the surface, they are the Artemis Accords, which several countries have signed up, right, to be a part of. But that is the extent of my knowledge on the international partnership as it relates to Artemis.
Thank you, Camille.
If we're out of questions, I do have one more.
Please.
Okay. So, Camille, I'd like to know, so when you started in the 90s, when you want to go into STEM, what was the spark that set the spark in you to get into STEM? What was it? Was it something you experienced as a child, or was it a parent, or was it another family member, or was it a television show or a movie? What was the spark?
Actually, it was a combination of things. It was growing up in a household where my parents, they instilled the importance of education. That was number one. One of three girls, my mom was like, you need to get your education, right? So that was one. Two, I was really good in math and science, and I went to an all-girls school environment where, as a girl, being able to do math and science was natural. There were no barriers to really doing math and science if that's what you love. So that environment really, was the foundation for me, building my confidence that I was good in it and I can pursue it. And then lastly, we had a family friend who was an engineer, and I thought that was such a unique profession or career because, you were only encouraged to be a doctor or a lawyer. And I knew I didn't want to do any of those. And so my love for planes and my love for math and science had me actually migrate to the US to study aeronautical engineering, believe it or not. And it was my freshman year when the Space Shuttle Challenger blew up. And in that moment, it changed my life. I set my sights on wanting to work for NASA, wanting to be an astronaut, wanting to design rockets and spacecraft. And really, it was 6 years after that I was driving into the gates of Kennedy Space Center. And the rest is history. That was 26 years ago. So it was really those pivotal foundational moments that really shaped, where I started.
Right. Awesome. And you don't know they're happening at the time until you look
don't. You don't.
Thank you, everyone, for joining us for the first keynote discussion. Thank you, Dr. Alleyne, and thank you, Cindy, for your time.
What a pleasure. Thank you so much for having me.
Thank you.